Welcome. Today we're talking special right triangles. Special right triangles are triangles that come up decently often, especially when you're dealing with trig and the unit circle, which is what we're going to be talking about next. And special right triangles are when you're dealing with 45, 45, 90 triangles and 30, 60, 90 triangles. And there are ways to come up with the answers very quickly because they just deal with the same ratios over and over and over again. Kind of like those Pythagorean triples, just things that come up really easily and that you tend to just memorize. So here we have a picture of a 45, 45, 90, and we have the sides we're calling x and the hypotenuse we're calling h. So if we were to set up the Pythagorean theorem, we would have x squared plus x squared equals h squared. Let's say we wanted to know what the hypotenuse equals. So let's solve for it. So that gives us 2x squared equals h squared. We would square root both sides. Well, an x is going to come out, so that gives us x square roots of 2 equals h. Okay, so instead of calling that h, we could replace that with just x roots of 2. So if we know one of the side lengths on a 45, 45, 90, then we can know that hypotenuse is just that side length times the square root of 2. Okay, now because we deal with x's and y's so often, sometimes I like to use a different letter. This isn't a super 45, 45, 90, but we'll pretend that those are equal. Okay, what if I say this is j, and this side is j, and this side is just j root 2. Okay, so these are your beautiful isosceles right triangles. Okay, now what if your hypotenuse is a whole number? Well, we could solve for j. What if I had to solve for j if we have a whole number? So we're going to say if your hypotenuse is a whole number, then j is going to just equal the number times the square root of 2 divided by 2. Okay, that's with the denominator rationalized because you have to have rationalized to numbers. The numbers. So we'll walk through that when we get to the example here in a minute. All right, so here it says find the missing sides of the triangles. Leave your answers in simplified radical form. Okay, so here the sides are marked, so I know this is a right isosceles triangle, so it's a 45, 45, 90. If I know one leg, I know the other leg. If I know the legs, I know the hypotenuse is just the leg times the square root of 2. Okay, so A is equal to 3 square roots of 2, and B is just equal to 3. Easy peasy lemon squeezy. Okay, so this time, let's say that we forgot or we weren't aware of that little note that I just made. So I know that my hypotenuse is equal to my leg times the square root of 2. So to solve for what my leg equals, I'm going to divide by square root of 2 on both sides. All right. So then I have 8 divided by the square root of 2 is equal to my leg. But we can't leave the square root of 2 in the denominator. So then we have to rationalize by multiplying both sides by the square root of 2. So then I have 8 square roots of 2 over 2. And then, so that's where it's that whole number times the square root of 2 over 2. And then the 2 divides into the 8 2 times. So 2 square roots of 2 is what our legs are equal to. So A is equal to 2 square roots of 2. And B is also equal to 2 square roots of 2. Okay, and C, we have that our hypotenuse is 4 square roots of 2, right? Which is the short side or the leg equal, the hypotenuse is the leg times the square root of 2. So that means our legs are just 4. Okay, so just memorize that ratio, leg or short, leg times square root of 2 is your hypotenuse, and the legs are equal. Okay. Now, when we have a 30, 60, 90, it's a little bit more difficult. So here we have an equilateral triangle drawn. So that means we have this side equal, the bottom's equal. But what if, we know this is 60 degrees and this is 60 degrees. What if I were to drop a line down there, right? And make it perpendicular. Well, that would become a 30-degree angle. That's perpendicular, so I end up with a 30, 60, 90. So let's say that I made this whole side, or this little piece from here to here. What if I call that X? That means that the hypotenuse of that new triangle I created is 2X. So how am I going to find the height of that triangle? Well, we know Pythagorean theorem, x squared plus that height squared is equal to 2x squared. Let's do some simplifying. So we get x squared plus h squared equals 4x squared. We're trying to figure out what the height equals. So we're going to solve. So we get 3x squared. We would square root, so h is equal to, x would come out of the square root, leaving our 3 underneath the square root. So the height, we're not going to call height anymore. We're going to leave it in terms of x, right? So we're going to say this is x square roots of 3. So now let's draw a new 30, 60, 90 and make it nice and pretty. Clean it up a little bit so we can look at it. There we go. Okay, we're going to call this side, let's pick a different letter, not X, because again, we're dealing with X's all the time. Let's say T. So we have our short side, and our hypotenuse is 2 times the short side, and then the long leg is the short side times the square root of 3. Okay, this is our 60-degree angle, and this one is our 30-degree angle. Okay. So again, there's our ratios that are good to us and help us. Okay, so find this missing side of the triangles, leave again in simplified radical form. So if I know the longest side, I know that the longest side is the hypotenuse. So if I take the hypotenuse, I divide it in 2, that gives me the short leg. So A in this case is 12, and then the long leg is equal to the short leg times the square root of 3. Okay, on this one, the short leg, which is 32, is the reference one. So then we take to get the long leg, we take the short leg, times it by the square root of 3. To get the hypotenuse, we take the short leg and double it. So 2 times 32 is 64. Super straightforward. Okay. Then the next one, this is not a hard one. Sorry. So A is equal to 22 divided by 2, which is 11. So A equals 11. And then B is the short side, which is the 11, times the square root of 3. And lastly, this is when it's hard, when we are given the long leg. So we know that the long leg is equal to the short leg times the square root of 3. So we could have said b squared 3, whatever. So then we have to do some work. So we get t is equal to 16 over the root 3, but we can't leave the root in the denominator. So we get 16 root 3 over 3. We can't simplify 16 root 3 over 3. So that means our short leg is 16 root 3 over 3. And our hypotenuse is 2 times that. So, come on screen, stay where I want you. So 16 root 3 over 3. If I times that by 2, what gets multiplied? Those two numbers do. So that's going to be 32 root 3 over 3 for our hypotenuse. Good luck.